Hello, welcome to the semester one redo. This is part one. Remember, this is an opportunity where you can get up to 10 bonus points. You're going to take a quiz next class. It will just be for bonus. If you get an A on it, you get 10 bonus points. If you don't get an A on it, you get to take it again. And then you'll get bonus points depending on how you get the second time. So, bonus points for everybody. Here we go. First thing is, I'm just going to run through this real quick. We did it in class, but if you need a little extra, we start with K is parallel to L, and this won't come into play until a little bit later, actually. We're going to, actually right there. All right, so K is parallel to L. That means nothing right now, but we'll come back to that. Let's go, the proof goes to 2 and 3. Now 2 and 3 make a linear pair. Linear pairs are supplementary. Supplementary adds up to 180. Now these three, I think there was a typo, so make sure that says 2 and 3 right there. These three always just go together. This is like the linear pair thing. This is like the linear pair thing, given linear pair definition of supplementary. All right. Always just go to linear pair implies supplementary, supplementary implies 180. Now, what we're going to end up doing is taking this 1 and this 2 and basically taking this 2 and replacing it with a 1 because they're the same. All right, that's basically what we're doing. And then basically, so 1 and 3 are supplementary. All right, so we got to get to the reason why we can substitute this 1 with this 2. All right, so forget that we did that. So here's the rest of it. In this diagram, angle 1 and angle 2 are in the same spot respectively in their cluster. This is the top left of this cluster of angles. This is the top left of this cluster of angles. So those are called corresponding angles. Now, here's where the parallel comes into play. When the lines are parallel, then the corresponding angles have to be congruent. And congruent means equal. And now I can basically take this said 2 plus 3 equals 180, and I can change it to 1 plus 3 equals 180. So I'm changing out the angle 1 here. I'm changing out the angle 2 with an angle 1. So this step is essentially the same as this thing, except we just changed out the 2 with a 1. And then that just basically proves that 1 and 3 are supplementary. They had 180, so they're supplementary. Okay, next. Actually, let's go down to number 4. This is what I did in class. We skipped down to number 4. To the untrained eye, these all look like right angles, but they're not. We know that. But what is the relationship between 1 and 6? Well, we'd probably say something like this. 1 and 5 are the same. 5 and 6 make 180. So therefore, 1 and 6 make 180, so they're supplementary. 1 and 6 must be supplementary. Anytime you got parallel, there's going to be something, so go ahead and take neither off. And then the last parallel question was this one. We're going to start this. We got parallel lines. It's kind of hard to see, actually, but those are parallel. All right, we got parallel lines. And we have ourselves a linear pair. We're going to start with the linear pair in this equation. Linear pairs always make supplementary, and supplementary makes 180. So we're going to solve that out. We get x. Then what I'm going to do is I'm going to go back and plug x in. And we can see here, with the parallel line thing, these angles have to be the same. These two. So if I plug x in here, I get 126, which makes this 126, which means I can make that equation, 9y equals 126. That's the end of the parallel line stuff. Let's go to number 8 now. In this picture, we had this picture. You have complementary, which makes a right angle. You have bisect, which makes 45-degree angles, because we're cutting them in half, cut a 90-degree in half. These are 45. And then we can label angle 1 3x minus 6, and we can see here that 3x minus 6 equals 45. solve it from there. All right, let's go back to number 5 and 6. The important part here is that you have to use this. Before you really start, use that. So what does 3y plus 3 equal? Well, it matches up with A and D. So C and D matches up. You have to match it up. You can't get this right if you don't match it up. You're not gonna be able to tell if it's 10 or 12. You have to match it up. So match it up before you really do anything. That's why I said 3y plus 3 equals 12 is able to solve for y. 2x matches up with angle D in this triangle, which matches up with angle B in this triangle. See how they're in the same spot? So these two match up, which is why I said 2x equals 30. Number 6, we got a 40-degree angle here, so we have a linear pair. We have an isosceles triangle, which makes these both 20 because they have to add up to 180. 20 plus 20 plus 140 is 180. These had to be the same, adding up to 180. This adds up to 90. You can see that. So this is 70 degrees right here. And then this has to add up to 180 for this triangle. It's a little puzzle, but you do get the answers there. Okay, back over on the front page onto a triangle proof. We are compiling and concluding. Compile and conclude. First, we get a given. That counts as an S for a side. Then we get another given, the bisector. Now it's this angle that's being bisected, which is why I said angle 1 is now congruent to angle 2. It counts as an angle, the definition of bisector. You have to state that this side is shared, which counts as an S. And now I have compiled. Here's my compilation. I've compiled my evidence, and here's my conclusion. Compile and conclude with side angle side. The next proof is basically the same. We compile and conclude. Check it out. A is congruent to D. Because it's given, that counts as an A. This side right here is being midpointed. So that's a midpoint, which makes that and that the same. That counts as an S. And I have that sentence right here. C is the midpoint of AD, hence because the midpoint, AC is congruent to CD. It counts as an S. We got our vertical angles going on with 1 and 2. So 1 and 2 are vertical angles, and that counts as an A. My first therefore the triangles are congruent by angle side angle. And second, these two here, B and F, there's B and there's F. They are corresponding parts. If they're in the same spot in two congruent triangles, then they're congruent themselves. And that, oh, one more. This is the last question. This was on the most recent test, actually. We graph them, graph the points, and we can do everything with slope. Do everything with slope. I'm telling you, just find the slopes. It makes it easy. Okay, first, does it pass the parallelogram test? Well, if you look at the slope of this, this is up 4 over 3. The slope is 4 over 3. And this slope here is up 4 over 3. The slope's 4 over 3. This slope is 0, and this slope is 0. So these are parallel. I should put that on here. These are parallel, and these are parallel. So it is a parallelogram. I figured that out with slope. Furthermore, it's definitely not a rectangle or square. Like I don't even need to check. That is definitely not a right angle. I can tell that. But what I should check is the diagonals. The slope of this diagonal is down 2 over 1. It's hard to see because I highlighted it. And then this slope of this diagonal is up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And those are opposite reciprocals, which makes this a right angle. We have ourselves a right angle. Therefore, if you have a If you have a perpendicular diagonals, that makes it a rhombus. All right, that's all I have to say about that. Again, we're gonna take a very similar quiz to this. If you get an A, then you get your 10 bonus points and you're done. If you don't get an A, we're gonna do it again. We're gonna go over it, we're gonna do it again. So let's see what happens.